Assalamualaikum and hello everyone. Welcome to our chemistry project presentation. Before we begin, let me introduce our group members. My name is Nikno Batrisha and meet my teammates Iza Mafuza Hanim, Aiza Farina Elisa, Ahmad Adam and Muhammad Aziz. Did you know that one of the main acids in grapes and also in wine is called tartaric acid? As Muslims, we may not consume wine, but that doesn't stop us from exploring its chemistry. Tartaric acid is not only found in wine, but also used in food, skincare, and even in pharmaceutical products. Tartaric acid gives wine its sour taste, maintains the color, and helps preserve the wine, making sure it lasts longer without spoiling. In this project, we will determine the percentage of tartaric acid in a wine by using basic analytical chemistry technique we had learned in class called acid-base titration, where a standardized solution of sodium hydroxide is used to neutralize the tartaric acid in the wine. Let's see how this works.
Moving on to titration and standardization. There are 6 main points that I want to talk about, which is objective of titration, titrant, primary standard indicator, and the importance of standardization. So what is the objective and why we do titration? So that we can determine the concentration solution using a known solution, which is sodium hydroxide. Next is titrant. In this experiment, we use standardization NaOH, which is a strong base, for titrant acidic solution. Primary standard in this experiment use KHP so that we can find the exact molarity of NaOH. The indicator that are used is phenolphthalein, which turn light pink at endpoint. Lastly, the importance of standardization is to ensure reliable and valid titration results in the wine analysis.
So now, I'm going to talk about the sodium hydroxide. We will need to ensure our safety first by wearing something appropriate and be cautious every time because the sodium hydroxide can be very corrosive and also generate heat when dissolving. Why do we need to prepare the sodium hydroxide? First, we will need some solid sodium hydroxide pellets or flakes, distilled water, volumetric flask, and glass rod. Here comes the step to prepare the sodium hydroxide solution. Firstly, we need to calculate the mass required by using the molarity, volume, and molar mass of the sodium hydroxide. Then, weigh the sodium hydroxide and pour it into the beaker. Secondly, pour up distilled water into the beaker and slowly adding the sodium hydroxide while stirring. Take a time to cool the solution to room temperature. Lastly, the cool solution of the sodium hydroxide can be transferred to a volumetric flask. Beaker and glass rod used to stir the solution is rinsed and poured into the volumetric flask. The solution then can be topped up with the distilled water until the calibration mark. The flask then will be closed using the stopper and mix it by invert it several times. Finally, the solution can be stored in the tight closed plastic bottle and then label the solution with its concentration. Then we will move on to the step to standardize the sodium hydroxide. First, we need to prepare the potassium hydrogen phthalate, which is KHP, while weighing about 0.4 to 0.5 the dry KHP. The KHP then will be transferred to a conical flask and dissolved with 20 or 25 distilled water. After that, 2 or 3 drops of phenolphthalein, which is the indicator, was added to the solution. As the KHP is acidic, the initial color will be colorless. Next, the burette was filled with sodium hydroxide solution and the initial volume will be recorded. Finally, the titration process can be started slowly by adding the sodium hydroxide to the KHP while swirling. Titration needs to be stopped when persistent pale pink color appears and lasts for 30 seconds. Don't forget to record the final burette volume as the titration need to be repeated at least 3 times for accuracy. I also put the balance equation and how to calculate at the below.
The next step is to analyze the wine sample. The first step, we take the 10 ml of wine and add 20 ml of distilled water into a 250 ml beaker. Next, we add 5 drops of phenolphthalein as an indicator. Next step is to titrate with NaOH that we did earlier until the solution turns light pink. And the last step is to record the initial and also the final reading of the burette. Don't forget that this also has to titrate at least 3 times. So this is the results for the standardization of NaOH. As you can see, we get the average molarity of NaOH is 0.13. This is for the results of content of tartaric acid inside the wine. The percentage of tartaric acid that we get is 0.51%.
Let's begin with the possible sources of error in this experiment. One of the main issues was over titration, which could lead to inaccurate measurement of the acid content. Another potential error is wrong computation. This includes mistake in calculation, data manipulation, or incorrect application of formula. All of these can affect the final result. Now, we are moving on to the conclusion. The tartaric acid content found in the wine sample was determined to be 0.51%, and this result indicates that the titration technique was performed correctly and effectively. Thus, we can conclude that the quality of wine was successfully analyzed using this method. This illustration shows the standard setup for a titration experiment. At the top, we have burette, which is used to accurately deliver the titrate, which is a solution of non-concentration. The burette is held securely in place using a burette clamp, which is attached to a retort stand for stability. Below the burette, we have a conical flask placed on a white tile. The conical flask contains the analyte or the solution being tested. We often mix it with an indicator to observe the endpoint of the titration. The white tile is used to make it easier to see the color change during the reaction. This setup ensures that the titrate is added drop by drop into the analyte, allowing for precise determination of the volume needed to reach the equivalence point. So these all are the references that my members and I refer for this video. Thank you for watching our video. Bye!